can tell, this is definitely not my normal recording studio, but that's actually pretty relevant to today's video because I want to be talking about the problem with CrowdStrike that happened recently, and that's actually why I'm stuck in this hotel room because I've been trying for the last few days to get back home, but CrowdStrike has obviously grounded all of the flights recently, and there's no way that I can actually get home right now, at least for a couple days. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream projects sooner. And in this video, I really want to talk about what happened with CrowdStrike really briefly if you haven't heard of it right now. Then I want to talk about why this actually happened, and then finally talk about what we can actually learn as developers from this to make sure problems like this don't actually happen in the future. So starting with what CrowdStrike really is, CrowdStrike is a tool that's a security-based kind of antivirus style tool that a lot of larger enterprise companies use to try to make sure that their applications are secure and they don't have any viruses or malware or anything like that. That's a really high-level overview of what it is, but in reality, it's not super important to understand what CrowdStrike itself is. The problem that we ran into is that CrowdStrike pushed out an update, and this update caused systems, specifically Windows machines, to crash as soon as they tried to boot up. So essentially, you just instantly crashed every single time you tried to boot up your Windows machine, which meant any software in the entire world that was running with CrowdStrike on a Windows machine was unable to function at all, which is why we had huge outages in airlines, banks, pretty much everywhere across the world. There was outages in pretty much every sector out there that was using this CrowdStrike software. Normally, when we have bugs and new updates to software, it doesn't bring such devastating effects to the actual world, and that's because usually the bugs in the software are much smaller and they're not causing systems to crash. And secondly, that's because most larger companies do not run on the latest updates for their software. They're always running at least one or two versions of older software to make sure that they're running on stable and well-tested software. They want to make sure when they update to the next version of the software that it's had weeks or months or even years of testing from other people to make sure that that software is good and ready to go. So you may be wondering, how did all of these major companies that should be having this system where they run on older versions of their software, how did they run into this particular problem? And the reason for this is because of something CrowdStrike actually did. CrowdStrike pushed this brand new update that they did, and instead of pushing it only to the newest version of their software, they pushed it to all the versions of their software. So the companies that are running 2 versions old or 3 versions old or 1 version old versions of CrowdStrike are actually being pushed this brand new update. So even though they're on this older version, they're still getting this brand new patch that's being put into their update. And this small update that CrowdStrike issued is what caused the issues. So even though companies had these precautions set in place to make sure that they were purposely running older versions of the software to prevent these types of bugs, CrowdStrike essentially went around that and said, it doesn't matter, we're going to be just overriding all of our updates that are out there, no matter how old they are, with this new patch that caused all of these huge problems. Now, I don't know how personally this made it through the testing on CrowdStrike, because if it obviously causes all Windows machines to instantly blue screen and crash, I don't see how that could have made it past the testing phase. It almost makes you wonder if there's something malicious going on there, but obviously there's no proof of that yet, so I don't really know. I can't say one way or the other, but it does seem very suspect that something like this would make it through testing, especially since this is a company that works with large-scale enterprise companies that need to have that really robust level of testing. So now that we kind of understand what CrowdStrike is and kind of why it impacted the software the way it did, I want to talk about what we can learn from this. And the first thing we can really learn from this is the technique of having older versions of software or making sure you only use specific versions of software. Unfortunately, in this particular scenario, the way CrowdStrike did things, this didn't actually solve the problem. But what I'm talking about is when you work at a larger company, almost always you're going to be restricted on what types of software you can install. You have to use specific versions. And when you're installing software for like maybe an NPM library you're installing into your project, you need to make sure you specify the exact version. And you're going to have a hard time using the latest version of almost any piece of software just because it needs to be tested and vetted by the IT or tech team on the actual company. And that way you're using older versions of the software and you're not updating to the newer versions until they've been tried and tested by other companies for at least weeks or months, however long it needs to be. So this is something that when I was a newer developer, I always thought was really annoying and difficult to work around because I was always using 1 or 2 versions old software and I was never able to use the latest and greatest features of things. And I just thought it was a dumb thing that they did. Obviously, as I got older in my career, I realized that this is actually something that's really important because otherwise, if you're always using the latest version of software, anytime a new bug gets pushed to that software, you're going to get that in your software that you're using for your application. And obviously, it's going to cause problems for your users. And billion-dollar massive companies, they cannot have these issues happening because it'll cost them millions or even billions of dollars of revenue if they're down for even just a short period of time. So one thing that we could take away from this that a lot of larger companies do is they have multiple versions of software. So they have what they consider their testing version of a particular piece of software. And that testing version is running on the latest and greatest version. It's the most up-to-date version of the software. They then have a staging version, which is kind of in between your development / testing, and it's in between production. It's kind of that middle ground. And this is usually running on maybe like one version back. So your testing version or your dev version is running on the latest version, and it's making sure that any bugs that come in from the latest version are caught before we push them further. Then we have the staging version that's running one version back, just to continue to test to make sure, is this version of software good? And then finally, your actual production code that's running out there in the wild, that is running on 2 versions back. Now, depending on the size of your company, you may only have a development and a production version, and you don't need that staging version. Or maybe you even have multiple stages in between, where you have maybe 3, 4 different stages instead of just 1 or 2. It really depends on the size of your company and the level of security that you need. But having this different tiered approach where you're always running 1 or 2 versions old on the most up-to-date production side of things, while on the more testing side of things, you're running the latest and greatest version, this makes it really easy for you to say, okay, you know what, this latest and greatest version is causing bugs in development. Let's make sure that those are fixed before we go ahead and start pushing that to our production site. So it just gives you a little bit of a buffer to make sure any new bugs that are introduced are caught in a development and testing environment before it actually gets pushed out to production. And production is just always running a few versions behind to make sure it has the most secure and most well-tested version of that code so you can ensure it works in your environment. As your company grows into a much larger company, this is something you're almost always going to want to do. But it's something you can even implement if you're a smaller developer working on a smaller project. You can maybe make sure you're not always using the bleeding edge version of something, and instead you just cut back a little bit on the versions just to make sure you have a slightly more stable experience. If you've used Next.js at all in the past, you may know that Next.js is kind of difficult in this aspect where some of the latest and greatest versions introduce some bugs, especially around development mode, which was really difficult and annoying to work with. While if you're working, 1 version back or even 2 versions back, it makes it so that you have a slightly better development experience. And you don't have to be back major versions. It can even just be minor versions. So instead of Next.js 14.4, if that's the latest version, you're running on like 14.2. So it just puts you a little bit behind the curve. You're not really missing out on a ton of things, but it makes sure that the other people can actually test and work out through all these bugs. And then once all those bugs are fixed, you can essentially come in and actually use that software like it's supposed to be used. Another really important thing we can learn from this is understanding the actual severity of certain software in your projects. Sometimes if you have a project, certain pieces of code in that project are really crucial to the actual working parts of your application. So if you have a library that's installed, such as React or Next.js, where your entire application is built on top of that, if there's a bug that gets pushed out to React or Next.js, your entire site is going to go down depending on the severity of that bug. So understanding how crucial certain libraries are to the functioning of your code is really important, because if those libraries go down for any reason or they have any bugs introduced into them, that could absolutely crash your entire application. This actually happened a little while back with the library called leftpad inside of NPM. This library was essentially deleted, and every single piece of code that depended on this very, very small library essentially was unable to work because this library no longer existed. And there was a huge problem for a short period of time while this was trying to get fixed in the JavaScript ecosystem. So the thing that you want to think about is when you're installing a third-party dependency into your code, whether you're copy pasting some code, whether you're coming in here and installing an NPM library, whatever it is that you're doing and you're depending on third-party code, you really want to consider how important is that code to your application and what are the risks of that code changing or breaking in the future. If the code is relatively easy for you to write on your own, maybe it's a better idea just to write that small little bit of code on your own instead of depending on a library. For example, this leftpad library was just like 5 lines of JavaScript code to add things to the beginning of a string. So if you wanted a string to have 5 zeros in the front of it, you could pass it to leftpad and put 5 zeros in front of it. That's a very easy bit of code to write yourself, but so many libraries depended on that, even really large libraries, and it was so deeply nested, it was something that you didn't even realize you were depending on until it was too late. So if you can, try to write the smaller, simpler code yourself, or even just copy paste the code from the library into your actual code base. Now, in lots of scenarios, this obviously won't work. For example, React is not something you can write yourself, and you can't just copy paste it into your code base because you want the most latest and up-to-date versions of it. But you just need to realize that when you're installing all these third-party libraries, you are opening yourself up to a potential level of risk that would not be there if you're not using those third-party libraries. And it's important to document how much you depend on each of those libraries and how crucial they are to the working of your application. Now, the final thing we can learn from this is what do you do when you have a catastrophic event like this? Let's say that you have left pad installed into your project, all of a sudden it gets deleted and your project goes down entirely. What can you do to mitigate these problems and try to help your customers? The very first thing that you need is some way to instantly push out an update to your page that is going to announce to users what the problem is. For example, if your page doesn't go entirely down, but maybe it stops working for some reason, it stops functioning, you need a way to instantly push out an update that notifies users, hey, we have this problem, and this problem, and we are currently working to fix it. Just letting the users know that there is a problem, you are aware of it, and you're working on fixing it, at least gives you some goodwill with the customer. Even if the page is down, they at least know that you're working to try to fix it. The next thing is you need to have a good system in place for being able to quickly swap out and fix these potential bugs. For example, if left pad is the thing causing the problem, what can you do to really quickly fix that? You could create your own hot patch, essentially write your own left pad and throw it in there in place of the left pad you're replacing, but just having some type of crucial system in place. What are the developers and team members that you need to have on call at all times in case something like this happens? Because in the case of the CrowdStrike thing, it happened essentially really early in the morning on Friday. A lot of people are probably sleeping, not at work. So what is your protocol for this type of, emergency situation? Your company and team needs to have a protocol for the people they need to contact and the things that they need to do. And even if you're a solo developer, writing out a plan of steps for yourself is really useful, because when you get into a crisis situation, it's very easy just to completely go blank and not know what to do. But if you have a set of procedures that you can follow, that makes it a lot easier to try to actually go ahead and fix this potential problem as quickly as possible. And we've actually seen this with the CrowdStrike problem. Some companies were able to get up and running really quickly and able to start resuming process immediately, while other companies, like the airline that I'm trying to fly on, took much longer to get the problem solved, and they're constantly delaying and canceling and pushing back things, and customers are obviously really upset, and they're losing millions or billions of dollars because of these laybacks. So really having that system in place is really important. With that said though, I really hope a problem like this does not happen in the future, and that companies are able to learn from the mistakes that happen now to hopefully make things more resilient in the future, so that we don't have worldwide problems like this when individual pieces of software go down. Now, if you enjoyed this video, I'm going to link a few other discussion style videos right over here. And with that said, thank you very much for watching and have a good day.